We now have the opportunity to graph an absolute value inequality. And we have two inequalities here. I went ahead and graphed this second one here. And I graphed it on the calculator. I'm going to graph the other one on the calculator for you. But I graphed this as an equality, and I did that so that we could just go ahead and once again show how we might use a test point to determine where to shade our solution set. And I'm doing this just in case you ever run into some kind of standardized test where they're not letting you use the calculator on a portion of it, and if this ever came up, that you would have a better idea of what to do. Now, in this second inequality, I see that I'm going to have two transformations. One, this 3 is going to create a dilation, just to review transformations for just a moment. And it's going to stretch this graph vertically. And it's got a translation, and this +1 is going to move this graph 1 unit to the left. And we see that that is so by what we're looking at. Now, I want to try to figure out which region to shade. And I've got inside the V-shaped absolute value graph, and I've got outside. So it's going to be one of those two. And I can still use the test point 0, 0, because it lies outside What do you want? I'm doing terrible. You're disturbing me. Sorry about that. So anyway, I can use 0, 0 because it's not lying on any of the lines of the graph. And if it gives, in using 0, 0, if that gives me a true statement, then I shade the region where the origin lies. And if not, I shade the opposite region. So let's go about that. So I'm going to substitute 0 for y greater than or equal to 3 times the absolute value of 0 plus 1. Well, of course, 0 plus 1 is 1, and the absolute value of positive 1 is 1. And so that's going to be 3, and I got 0 is greater than or equal to 3. Excuse me just a minute again. Hello. I don't care. All right, and I asked myself, is 0 greater than 3? Well, of course it's not. And so therefore, I'm going to shade the region opposite of that. And so my solution set is going to lie inside the V because my test point was outside the V. All right, we're going to just quickly graph this other one using our graphing calculator. Okay, well, here we are on our graphing calculator, and we're going to graph that first inequality that we saw, which was y is less than or equal to 2 times the absolute value of x plus 3. So the first thing I'm going to do is I'm going to go over here and change my inequality, and I have the inequality app up and running. So I'm going to highlight that, I'm going to hit enter. And I'm going to go down to what y is what. So let's see, I need a less than or equal to, and there it is. I'm going to say, okay, I want to use that. And now we're going to put in the inequality expression 2 times. I got to go to absolute, so I hit math, go to number, choose option 1, ABS absolute. and it's x, close my absolute symbols, and now it's plus 3. So now once again, that 2, the coefficient of that 2 times the absolute value of x, that's going to give us a dilation. It's going to stretch this graph vertically. And the plus 3 is going to give us a vertical translation, a vertical shift up by 3. It's not inside the absolute value symbol, therefore it's going to be vertical. And let's graph this thing right quick. And I can see that my solution set lies outside the V-shaped absolute value symbol. And just real quickly, if I just put in what would be the absolute value of 0 is 0, 2 times 0 is 0, but I still had the plus 3. Is 0 less than or equal to 3? Well, of course it is. And if I were using that as a test point, the origin lies on the outside of the absolute value symbol, and therefore that's why it is shaded. Don't call me with some kind of stupid thing. You might just get fussed at.